In this lesson, we're going to be solving this equation that's displayed on the screen. So in parentheses, 3 multiplied by x exponential x equal to 3 exponential x plus 10. So solution, let me write this question. So we have 3 multiplied by x exponential x is equal to 3 exponential x plus 10. So we have invisibles one here as the exponent of 3 and x, and then we are going to multiply these exponents with x according to the law of indices. So we're going to have 3 exponential x multiplied by x exponential x equal to, now this 3 exponential x plus 10, just like we have exponential m plus n is equal to a exponential m multiplied by a exponential n. We are going to write this 3 exponential x plus 10 in this form. So it's going to be 3 exponential x multiplied by 3 exponential 10. So if you look at this equation, you see that these 3 exponential x and 3 exponential x are the same, so they are going to cancel out, and they are going to have x exponential x is equal to 3 exponential 10. Now, no matter your knowledge of algebra and the depth of experience in solving it, you cannot solve this equation using that approach. So we are going to use Lambert W function to solve this equation. And so Lambert W function states that if x exponential x is equals to a, then you apply Lambert W function to both sides of the equation equal to WA. When you do this, your x value will be equal to Lambert multiplied by a, where this is a constant. So let's go ahead and write this equation to be in the form of x exponential x equal to a. So when we achieve that, we now apply the Lambert W function to it. So let me wipe this side of the screen. And so we're going to have x exponential x is equal to 3 exponential 10. So let's apply natural logarithm to both sides. I have ln x exponential x equal to ln 3 exponential 10. And so let's go ahead and bring this s in front of this log and then 10 in front of this. So when we do that, we have x ln x equal to 10 ln 3. So let's take note of this equation, or rather let's call it equation I. So the next thing we're going to do here is to do some substitution. So we say let y equal to ln x. So if y is equal to ln x, remember that's e as the base of this natural logarithm. So our x is now going to be equals to e raised to the power y. So it's going to be e exponential y. And so in this equation 1, anywhere we see x, we represent it with e exponential y. Anywhere we see ln x, we represent it with y. Now, when we replace x, we are going to have e raised to the power y, and then when we replace ln x, we are going to have y, now equal to 10 ln 3. So let's rewrite this equation to y exponential y equals to 10 ln 3. As you can see, we've written this equation to the form we want it to be, which is x times e exponential x equal to a. Now we have y times e exponential y equal to 10 ln 3. Now this is equals to 10 ln 3. So the next thing we're going to do now is to apply the Lambert W function to both sides of the equation. So you have Lambert W of y as e raised to power y equal to Lambert W of 10 ln 3. So when we do that, our y is going to be equals to w into 10 ln 3. So let's substitute back y is equals to ln x to this equation. So we are going to replace y with ln x. So we're going to have ln x is equals to w into 10 ln 3. And so as we know, there's e as the base of this natural logarithm. So our x is now going to be equal to e exponential w into 10 ln 3. Now in another form, it can be written as x is equal to 10 ln 3 over w into 10 ln 3. Now this is your exact value of x. Now to get the numerical value of x, it's going to be 10 ln 3. Now we are going to look up the value of w 10 ln 3 in the product logarithm calculator. So if you look at it, you see that you are going to get the value of 1.80569, and by the time you compute this in your calculator, you are going to have x as 6.084. So this is the final answer. Please remember to subscribe and turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. Thank you for watching.